Good morning, everyone. Good morning, good response. I'm glad to see so many people in the room, and I'm glad to see myself here as well. It's a little early for me, but I remember that exactly 3 years ago, I stood right here in that same room, and alongside me there was a gentleman called Ryan Crocker. You may know him. He was a local Microsoft guy from the subsidiary. Now he is up in Redmond in the document DB team. And back then, 3 years ago, we had exactly the same title on the screen, Overview of Azure Networking. And back then, we were talking about connecting virtual machines together, and we were pinging one machine from, running in Azure to another machine running in Azure, and we were very proud that they can see each other and talk to each other. And you had a virtual network. And then questions started popping up. Okay, what does that mean to have a machine in a subnet on Azure? And how do you actually control the traffic? And we didn't have a very good answer to that. So what I'm trying to say is that the networking space, in the Azure platform, was nascent about 3 years ago. And I'm very, very proud to stand here in front of you today and say hand on heart that what you have on Azure as a networking stack, as networking capabilities, is very, very close to what you do on premises today in your own data center or environment, whatever setup you have there. And this is probably the biggest message that I want you to take away from this session. I sort of opened up with this, and I'll probably close with that same statement so that you remember it. So my name is Emil Velinov. I'm part of a team from Redmond called the Azure Customer Advisory Team. I'm actually the Australia and New Zealand resource of that team. So I'm based here out of Auckland, covering projects and opportunities in Australia and New Zealand, and sometimes extending into Southeast Asia as well. So again, the title of the session today, Overview of the Microsoft Azure Networking Capabilities, focusing on some of the new enhancements that we have in the platform over the last year or so. And this is a very, very quick overview of what we'll be talking about. It's sort of our agenda, if you wish. So we are going to talk about the virtual networking, or the VNets, and what is new in that space. The first one is the network security groups. Not really a new feature. It has been around for 10, 11 months now, but it is a fundamental one for networking. So I'm going to talk about that a little bit. User-defined routes, a very popular ask for any corporate environment. Public IP addresses and public IP address mobility is something else that we will touch on. And you can now have multiple load-balanced IP addresses in front of the same virtual machines and cloud services. In fact, that's not the right statement. In front of virtual machines, multiple load-balanced IPs do not apply to cloud services just as yet. Then the latest probably addition to the platform, in fact, it is still in preview, the DNS hosting service. So you can host your DNS records on Azure, obviously for proximity and everything else. Azure Resource Manager is a new way of managing the Azure platform. It is a consistent API that sits in front of all services in the Azure platform, including obviously virtual networks, virtual machines, and storage. So the difference there is that we are moving away from imperative code-based management and trying to get people onto declarative management of their end-to-end Azure solution, whether it is platform as a service in the face of SQL database, a platform as a service cache, or whether it is virtual machines with virtual networks, or any mix of these capabilities. Excuse me. Network virtual appliances. That whole space has evolved very, very quickly over the last 12 months with the virtual appliance ecosystem just exploding. And you'll see I'll put up some names on the screen or brands that play in that space. So we are constantly working to increase that partner ecosystem as well. And this is for your benefit so that you continue to work on Azure with the same vendors and the same appliances that you have in your own data centers today. ExpressRoute has seen a bunch of enhancements. ExpressRoute is the Microsoft offering for private connectivity into the Azure environment, into the Azure cloud. And we now have a premium add-on offering. I'll talk more about that later, as well as connectivity to Office 365 is coming. In fact, it is in the process of being rolled out. A bunch of enhancements in the hybrid connectivity space as well, in the face of VPN offerings and coexistence between ExpressRoute circuits into your virtual networks, as well as IPsec-based over the internet VPN tunnels. So with that, let's not lose any more time because I have a lot to cover. You would have seen that slide a gazillion of times now, and I'm not going to talk about what the three circles are. I only want to highlight that considering those areas of focus for Microsoft, networking is right, left, and center in order for Microsoft to deliver on that mission, right? So with that in mind, another slide that you'd have probably seen, we have 19 regions, 19 Azure regions across the world, covering pretty much any geographic point. Something happened here that was not expected to happen. Anyway, so the 19 regions, let me skip through this. The 19 regions that we have, they are connected through a Microsoft-owned and operated wide area network, which is the backbone of our Azure connectivity across the data centers. I guess you can figure out that there is a world map that should be shown behind all these things. I don't know what happened to the world map. Probably the world disappeared or shrunk so much that it's somewhere in the middle and we just can't see it. But it is important to keep in mind of the throughput and the layout of that backbone network that we have, because as we are going to hear more about later on in the deck, that backbone can be yours. This is very important. This is a differentiating factor of Microsoft and the Azure platform compared to the competition. You can actually get your traffic on that backbone. I will talk about the topology in a few moments. I'm seriously struggling with controlling those slides. Anyway, so how are we going to achieve hyperscale of the Azure network stack? Okay, so when we started out with Azure, we had a very classic network design with huge layer 2 behind and then fronted by layer 3 nodes. What that meant is that if you are coming out from the internet into the Azure network and you need to hit a node such as storage, for example, somewhere at the back end, that was all good. However, if you had a lot of data in a bunch of storage nodes at the back end, and that data had to travel to websites, for example, which is probably to the far right in that 3 topology, then the network wasn't that performant, and there were bottlenecks of the traffic, moving up and down and sideways and all that sort of thing. So over the last 3 years, we have been hard at work to change that architecture completely seamlessly. And again, I have no idea what happened to the images. But if you look at that tree-like structure, now it is all layer 3 mesh-like topology. So sideways traffic going within Azure between the different nodes and services doesn't need to traverse that crazy structure that we used to have in the past. Much more scalable, right? Because of that mesh topology, it's really easy for us to reroute traffic and balance traffic without impacting too much the actual length that the packets have to travel. So That is giving us a huge level of agility to deploy new hardware into our data centers, as well as optimize traffic that travels internally between different Azure services. Imagine, for example, a Hadoop cluster on HD Insight that is hosting petabytes of data, and you need to move that data to, I don't know, maybe a SQL data warehouse. This is huge traffic, right? So with that new layer 3 mesh-like topology, we can do that much, much faster compared to the past. So it's all about, so within the data centers, our own networks and everything on Azure is SDN based, so software-defined networks. And what is that SDN thing all about? Historically, when you need to network stuff, you basically buy the hardware switches, and they are basically an appliance that you purchase from the vendor, and then you wire up the appliance in a certain way that you want according to the design that you worked on for the previous 2 months, and then you configure the appliance, and that was somewhat static, or someone need to go in and rewire the appliance if you had to make a change, reconfigure it, and so on and so forth. This is expensive and doesn't work at scale, right? And this is exactly the challenge that SDNs address. How do we address this? We basically look at the network from 3 different it's a layered stack of 3 different capabilities. The first one is what we call control plane. This is all our, well, actually the management plane, no, the control plane, which is where we basically put the hypervisor on top of the commodity hardware, so this is not specialized software. And then it's available for the next plane, which is the management plane, to come in and actually configure dynamically based on software and programmability, configure the network in a way that you want or the way that we want it to work. And then you have the data plane. This is your own traffic, which is actually subject to control, such as ACOs, for example. So if you want to define ACOs within your virtual network, between your subnets in the virtual network, this is relevant there. And at the bottom, I have sort of an obvious example of how those 3 planes relate to an actual activity that you or Microsoft performs. OK, so putting everything together into a single view. In Azure, obviously, we all know, or now we do, that you can define a virtual network, which is an address space that you own. And inside the virtual network, you do typical things like defining and managing subnets, defining network security groups that you attach to those subnets. You can, of course, provision virtual machines inside the subnets. You can apply network security groups to the virtual machines themselves. So there is a 2-tier approach to network security. The first tier is when you apply a network security group to the virtual machine, and the second layer is when you apply a network security group to the subnet that the virtual machine is part of, with an asterisk alongside that statement, because you can actually now have virtual machines with multiple NICs, whereby each NIC is attached to a different subnet. So you can have basically multi-homed virtual machines that are part of multiple subnets in the virtual network. So without actually advancing to that, the new addition to the network control capabilities is that you can now define your own custom routes, and you can decide exactly how the traffic within a subnet leaves that subnet or doesn't leave the subnet, or where it is directed to, and we'll see a detailed example of this in a few moments. In fact, the demo that I'm going to do relates to that capability, or partially relates to that capability as well. So once you define that virtual network, you choose how you define that virtual network. Of course, the next step from here is if you want to have, and I want to emphasize this, if you want to have external internet connectivity to the infrastructure that you have in that virtual network. If you don't want to have that connectivity, absolutely fine. You can completely close the virtual network to the internet and have no routable public TCP/IP packets into your virtual network. This is what a lot of people do not realize, that you can close the environment completely to external traffic. However, of course, if you do want to have internet access to the virtual network, then you have a bunch of control knobs that you control there. So you can have either dynamic or reserved public IP addresses. So if you don't want your IP address to change, we guarantee this. One detail here that I want to clarify is that the reserved IP addresses are actually Microsoft issued. Right, so they need to be in our address space that we own. You can't just go, okay, reserve IP address 199.245 dot something something, right? That's a public IP address that Microsoft doesn't own. Therefore, you can't reserve that for an Azure endpoint. You can now have also direct virtual machine access. So this is the scenario whereby you might want to deploy an FTP server, which is part of the virtual network. And of course, you want to open the FTP port along with a set of dynamic ports or whatnot. And it doesn't make sense for that public IP address to be subject to load balancing or any sort of advanced routing. So you just basically punch a tunnel through to that virtual machine directly from the internet. Load balancing is a natural capability that you need for, especially for cloud solutions when we are talking about massive scale, web farms, all that sort of thing. Then you basically need a robust load balancing in front. DNS services, this is, I mentioned, a new service. We can basically host your DNS names. And then the other DNS-related service is global DNS routing, which is a service called Traffic Manager. And we'll spend a little bit of time on that. Last but not least, all networking into the data centers is subject to Microsoft denial of service attack monitoring and proactive measures as well. I would say that we have, Microsoft, as you can imagine, is constantly under attack. Literally every second, if not even every millisecond, there are people trying to hack the network. We haven't had any breaches that I'm aware of, any major breaches, right? Denial of service has become extremely, extremely, extremely advanced in the cloud platform, right? This is more than you, I, or anyone with general IT skills or even specialized networking and network security skills can achieve on their own. There is an army, I'm not joking, an army of security experts within Microsoft who do that day in and day out. If you have a team of 20 security people in your organization, right, and they're committed to security, we will match that times X, right? And again, those are hand-picked security experts from around the world. Now, if you are after details around how DDoS works within the Azure platform, we can't give you this because, the first measure is obscurity. This is not the only one, I'm not saying, but this is the very first one. Obscurity in that space is good to have. Okay, so the last bit in that big mix here is the connectivity to your on-premises environment or private cloud environment, whatever you have running today, right? And as I implied earlier on, you can take two paths there. The first one is IP stack-based VPN tunneling from your virtual networks running in Azure down to your on-premises environment, obviously connecting a router. And the other approach, which is more enterprise-ready, is the private network and private connectivity into the Azure platform and into virtual networks, as well as public cloud services. right? This is important to understand. So ExpressRoute doesn't just connect your data center to a virtual network within Azure. It connects you and it hosts the traffic that you issue from on-premises over to public Azure services, such as storage, for example. Right? So even your storage-related traffic doesn't leak out to the internet with an ExpressRoute connection. Okay, so let's double-click into each one of those areas. The first one that we are going to talk about is DNS service. This is DNS hosting. This is not just a DNS register. In fact, you need to register your domain name somewhere, and then we are going to host that for you, which means that you need to basically set up delegation for your domain name to hit the Microsoft Azure DNS hosting service. And then the other one is Traffic Manager, which is a global service for global DNS routing to your Azure deployments. In other words, you can basically have, in fact, let's advance here and talk again about Azure DNS. It is ultra available. Why? Because we have, and that map is missing again. So we have obviously multiple edge locations that host our DNS hosting service, and resolution is anycast based. So that means that if you are doing an NS lookup, you are going to hit most likely the closest one, at least from latency point of view, of those edge services. It is going to reply, and you are going to get the fastest resolution time possible, right? If one of those nodes dies for whatever reason or disappears or gets disconnected from the internet, the anycast query is going to be responded to by one of the other nodes. So this is why it is ultra available worldwide. So the next service that plays in that space is Traffic Manager, which is a layer on top of DNS hosting. So if you have multiple deployments of the same functionality around the world, so you have a deployment that serves your European customers and a deployment that serves your North American customers and a deployment that serves Australia and New Zealand and maybe Singapore or wherever somewhere in our part of the world here, you can put Traffic Manager, which is a DNS a routing service, basically DNS-based routing service. And then within Traffic Manager, you configure routing policies. And you can have a policy which is latency-based. So you can basically instruct Traffic Manager, go to the deployment that is going to respond fastest to that user coming out of New Zealand. And that's going to be the deployment in the Australian data centers. And respectively, if a user from Brazil, for example, tries to connect to our global domain name hosted by Traffic Manager, they will be directed most likely to the North American deployment of our solution. And again, you can have different routing policies such as round robin across these three deployments. You can have failover to say that, you know, if Europe disappears, then route those European users automatically to the North American deployment. And you can have also nested policies. So you can basically say, okay, European users go to a European deployment, but what sits behind the European deployment is actually two physical European deployments, whereby now you start routing not on latency, but maybe on round robin. Right? So you have a deployment in Dublin, a deployment in Amsterdam, and then you just round robin the user traffic across these two. But again, if a European user hits those that DNS name, they're guaranteed to go to one of the European data centers, which is determined by the nested policy underneath. All right. So in the space of internet connectivity again, so you can have public IP addresses. We mentioned that in front of virtual machines. The picture, luckily, which appears on the screen this time, depicts that. So in front of the same virtual machines, you can have a load-balanced public IP address, which may be reserved if you choose to do so. And you can have dedicated IP addresses, still public, to each one of the virtual machines. And a user can choose how they want to connect. So, for terminal services or RDP, you might go directly to the public IP address of the virtual machine that you want to connect to. And for your web app traffic, you just hit the public load balanced VIP address. All right. Another new feature that we've announced relatively recently is multiple IP addresses per deployment or per cloud service. And the most common scenario for this is where you want to basically have different SSL certificates hitting the same underlying infrastructure. So if you have a website, if you have a web server hosting multiple websites, each of which requires a different SSL certificate, then you just configure that exact topology. Multiple IP addresses, public IP addresses, each of which has different SSL certificate, and then at the back end you direct to the port for the site that this public address maps to effectively. All right, so I mentioned reserved IP addresses, and they have been in the platform for some time now. But what is interesting, okay, something's happened to the pictures. What is interesting now is that you can move the public IP address from one backend deployment to another backend deployment. This is particularly useful if you want to do effectively a swap between a staging UAT environment and staging and production. Let's not mix UAT in here. So if you have staging and production, this is how you do it. You test your staging environment, you are happy with it at the end, and then you just move that public reserved IP address from the staging environment to point to the production. So this has been there with the mobility for cloud services, the public IP swap for cloud services, but now it is generic to even to infrastructure as a service. Okay, virtual networks and security, an important topic. So bring your own network. This is really what it is, right? You basically define the address space of the virtual network. You define your subnets and the address space for each subnet. What is new here is that you can actually bring publicly looking IP addresses as private IP addresses into the virtual network. And just if you get confused about what this means, I was confused initially when we were talking about that feature. And the scenario that we usually use as a canonical example of this, for very large organizations, when they acquire new companies and merge, the internal IP addresses overlap. So how do you solve this if you want to move some of that infrastructure from the acquisitions into the cloud, right, and not overlap with your on-premises private address spaces? You basically bring the public IP addresses into the virtual network. At that point in time, they are actually not public anymore, and as long as you treat them from your own on-premises infrastructure as private in terms of routing through your routers, right? And you direct the traffic to the virtual network where they live, everybody is happy, right? So there is no clashes in the IP address spaces with your existing data center and what you are hosting on Azure. The subnets we mentioned a bunch of times, you can secure them with network security groups. Those are bidirectional, so you can secure traffic into the subnet as well as what goes out of the subnet. And finally, control the traffic with user-defined routes per subnet, per virtual machine, and per NIC as well, with the latest edition of multiple NICs per virtual machine. All right. So this is effectively what I just described with the multiple subnets and the security groups in between. A typical example here is where you have a front-end subnet hosting your web infrastructure, or maybe your web application firewall appliances. Then you have a middle-tier subnet and a backend that is hosting your databases, and you allow traffic from the front-end network to hit your APIs that live in the middle tier or app tier subnet, but front-end traffic cannot hit the database servers directly, so you secure the environment that way. right? So it is sort of self-explanatory. If you have been living and breathing in the networking space, you'll be happy to see that picture because you are all familiar with it. User-defined routes. So as I mentioned when I opened the talk, virtual networks inside the virtual network have been completely open in terms of how traffic flows between virtual machines, meaning that even if you had defined subnets previously, right, traffic from any subnet will hit directly the target virtual machine, even if it lives in a completely different subnet. In other words, subnets didn't really have any networking semantics, right, in the past. Now they do. And user-defined routing is part of those semantics. So that's the state as it used to be, right? Anybody can go anywhere, including out to the internet. But now you can actually attach user-defined routes and control traffic. To say that for front-end subnets, I do allow outbound internet connectivity and inbound internet connectivity, of course. But then, when a front-end server needs to talk to my back-end databases, they actually have to go through a virtual appliance, which is that missing connection at the bottom. Right? This missing bit depicts the virtual appliance that controls the traffic and secures the traffic between the subnets rather than going directly through the purple box in the middle from the front end to the back end. Multiple NICs, that's self-explanatory. Probably the biggest point that I want to make here is that now you can have 16 NICs per virtual machine. This satisfies pretty much all requirements, right? In the past, we had virtual appliance vendors that are dependent on having multiple NICs and a large number of them. We solve that requirement with 16 NICs support now, meaning that we can onboard those virtual appliances into Azure, no problem. Okay, this is the network security all-up picture. For obviously external traffic coming from the internet. It is a layered approach, defense in depth. So you start with the DDoS protection that we provide out of the box, completely transparent to you. Then you can define your ACOs for any sort of public IP addresses for virtual machines, for example. Then you have, of course, the virtual network isolation, which is hypervised at the hypervisor level. Then you have the network security groups that work across the subnets inside the virtual network you define. Finally, you have the firewall, the Windows firewall, which lives inside the guest VM that you own and operate. And finally, you have the workload running in that virtual machine. You can control everything past the DDoS layer, right? Everything else you control fully. And that takes us to the demo. So the demo, just to explain what we'll be doing, it's sort of a simplified version of a DMZ, very, very simplified version of a DMZ. I have a front-end network, which is the 10.0.1 address space. Let's very quickly have a look at. Okay, so 10.0.1 is the front-end subnet. 10.0.3 is the back-end subnet, and we want to control and secure the traffic between the two, right? So here is the subnet topology that I have. We are particularly interested in the first two, the .1 and the .3 address spaces. In the front-end subnet, I have two web servers, and I have what I call a firewall server as well. And then in the back-end subnet, the .3 one, I have a management server or a database server. We can pretend that it is anything that we want, okay? So let me jump onto one of the web front-end servers living in the front-end subnet. And I have a psping command there going to the .3 backend server, right? So this is traversing from the front end subnet to the back end subnet. We'll run that command, and we'll see that we have a latency of the ping command slightly less than 1 millisecond, which is overall pretty good, right? The other interesting thing that I want to do here is run a trace route command back to that management server from the front-end subnet. And in a moment, we'll see that this is a direct path, from the front end to the back end server. There is no intermediaries. So the next thing that I'm going to do, and I have a bunch of scripts here, I want to show you a definition of a routing table. Actually, let me quit out of this and go into my Azure CLI tooling. I'm basically getting details about a routing table that I have predefined inside my Azure environment. It's still not attached to any virtual network. It is just literally the definition of a routing table. And what we will see is that we have a routing rule that says traffic to the .3 subnet needs to actually go through a first hop, which is the address of the firewall virtual machine running in the front-end subnet. Okay, so 2 web servers, firewall, right? Anything that needs to go to the back end, in terms of traffic path, it will go to the firewall first, and then the firewall is going to forward the traffic to the back end subnet. Okay? So this is the rule. Again, this is purely just a metadata definition of that rule. Then the next thing that we are going to do here is attach that rule to the front-end subnet. And this is this command. So we'll paste this here. The important things here is that I'm basically attaching my front-end forward firewall routing, right, to the front-end subnet. So let's quickly do that, or not so quickly. So these commands take a few seconds. And more importantly, they take another few seconds after they complete. So the change is not absolutely instantaneous after the command completes. It's pretty fast. It's within seconds usually, but not instantaneous. Something to keep in mind. I got caught out by this a few times where I make a change and I sort of have the expectation that the change is going to be immediately applicable. But the request still needs to go through that software-defined network, and we still need to reconfigure the virtual networking at that level, which is why it takes a few seconds. Okay, hopefully, oh, there we go. There is some progress. I was getting concerned that nothing is happening, but something is happening. So basically what we are trying to do at the moment behind that commandlet here, we are looking up the current definition of the front-end subnet. We are checking to see if some routing rules already apply, and then we are going to put the new definition for the routing table and attach it to that front-end subnet. What is really important to understand here is that this is done completely outside of the guest virtual machines. So even if someone compromises the virtual machine itself, they can't control that sort of thing, right? It is out of host security rather than in-host security, which is the case with the Windows firewall. Okay, this is going somewhat slower than what I was hoping for, but we'll get there. Let's see in the meantime. Okay, so it's basically saying setting the subnet blah. So this is updating the subnet definition with the network with the routing table. I hope not all my commands are going to take that long, because this will take us to the end of the session pretty much. I may shorten the demo, because the next step in the demo was to show you layering on top of this a network security group, right? Because that has nothing to do with preventing traffic. It only has to do with routing traffic down a particular path, right? So I may skip the network security group if it is really that slow, but we'll see how it goes. Okay, so the command has completed. The front-end subnet is now subject to that routing table rules that we have seen before. Oh, okay, so if you look up, most of the ping times here are sub-millisecond, and at some point in time, we'll see how that sub-millisecond goes up to 1.3, 1.4 milliseconds because of the extra hop. Traffic now from the web server that we are sitting on right now needs to first go to the firewall server on the front-end subnet, and then the firewall server is going to do IP forwarding to the backend. So we are introducing an extra leg in that network path. Eventually it will happen. Okay, so while this is happening, let's start a command to layer a network security rule on top of this. So let me copy this. And I'll paste that into PowerShell, and I'll explain what this does. Okay, so I'm not sure whether you guys can see. If you can't, I'll try to zoom in. Okay, so we are basically saying, for the Azure network, create an NSG rule, network security group rule, which applies to the backend subnet, right? And the rule is called deny front. It goes to the next page. How do we go to the next page? Let's see. Okay, so deny front-end inbound for all the protocols where the source IP address is in that address space, which is our front-end subnet address space, for all the ports, right? Any destination IP address in the backend subnet, obviously, since we are creating that in the backend subnet. And we want to deny traffic rather than allow. The direction is for inbound traffic, okay? So let's jump onto the VM. Okay, so the execution times of the ping command you see have increased. And if I do a trace route now, we'll see that we first hit the firewall server, and then we go to the backend database or management server, whatever it is. Right, so the first hop is still in the front-end address space, the .11. This is the IP address of the firewall server, and then we hit the backend server from there. Now, that firewall server could be a virtual appliance, right, which you manage. It's completely in your control. You can do, packet inspection, packet compression, whatever you want to do, whatever the appliance is capable of doing. Okay, so let's create that network security group rule to deny traffic from the front-end subnet. And again, it will take a while. Okay, so yeah, I'll skip that part of the demo, just in the interest of time. I mean, I was thinking of showing you one more capability, and I'll just talk to that rather than do it. On the Azure load balancer, so we have two web servers here, right, in the front end, right? And they are load balanced as far as external traffic coming into the network is concerned. The load balancer, until 5, 6, 7 months ago, was doing round robin basically between the virtual machines that form a farm, right? Which is not advanced enough. I mean, to start with, it is a layer 4 load balancing. It's not layer 7. But now you have the option of creating a routing rule and load distribution, which is actually source IP affinitized. Okay, so you can, that means that traffic from the same IP, internet IP, will be hitting the same backend server. If you are keeping, a shopping cart or something like that in memory, which is obviously affinitized to a particular server. So that scenario is possible. But again, this relies on a source IP address. So if you come from a corporate space where you are behind a proxy, it's likely that all your users will appear to be coming from the same source IP address. And this is where you need to introduce something else, which does layer 7 load balancing, which is cookie affinity or something like that, right? And we have actually a new service in Azure called the Azure Application Gateway, which does layer 7 load balancing. We'll talk about that in a few moments. Okay, so now the network security rule has been applied OK, and we'll see that the ping command has stopped working because I denied all. Of course, I can always, because the ping at the moment is on port 3389, which is RDP, I can always create another rule that does allow that specific port. In other words, we have denied everything, but we are going to allow 3389. Or in the case of SQL, 1433, for example, right? Okay. Cool. I think that will conclude the demo, and we'll continue talking about network appliances. This is that hypothetical firewall that we just had in the front-end subnet, routing traffic to the back-end subnet. So what could this virtual machine be? Okay. So there are two things that we are focusing on in the space of network virtual appliances. The first one is first-party appliances, such as what I just discussed, the application gateway, the Azure Application Gateway, which is a layer 7 load balancer. We'll talk a little bit about that. As well as, in fact, we are even more focusing on third-party virtual network appliances, the stuff that you are already familiar with. This is the F5s and the Barracudas and the Steelheads from Riverbed. All these appliances have now, or many of those appliances now have been certified to run on the Azure platform as a virtual appliance. So what are the capabilities that you can expect out of these appliances? Classic firewalling, intrusion detection and protection services, additional routing capabilities if you need them. All of these scenarios light up based on the previous capabilities that we discussed, multiple NIC addresses, multiple front-end IP addresses. There is a dependency in many of those appliances on those capabilities, which is why now this ecosystem has sort of gone like this. You know, from very few being certified and capable with their existing capabilities to run on Azure, now with the expanded networking feature set that we have, many of those just work. They don't need to change anything, and they just need to go through a little bit of validation and certification process within Microsoft. So how do you bring one of those virtual appliances into your virtual network? The answer is the Azure Marketplace. This is where those vendors, after going through that certification process, publish their virtual appliances in the form of virtual images. You go to the Azure Marketplace and you go, I want to stand up an instance or a virtual machine of appliance X, right? And that shows up in your virtual network. You configure it to live in whatever subnet or subnets this appliance needs to run in, and you configure it again exactly the same way as you used to do on premises. For I would say about 90% of those virtual appliances, there is one-to-one parity in the feature set of what you have on premises today and what your experience is going to be here. It's the same thing. It's just virtualized. They create the VHD. They publish it to the Azure Marketplace. We validate it, and away you go. So no difference from what you have been doing. Okay, a little bit more about the application gateway service that we brought into the platform. It is a virtual appliance, even though you don't sort of see it that way. You can manage it through PowerShell and configure it through PowerShell. So for all practical purposes, it just looks like platform as a service, but physically it is actually a virtual appliance that gets provisioned by that management API that we have inside your virtual network. And with that appliance, you can basically do two things primarily. The first one is layer 7 load balancing, okay, cookie affinity and all that. So even if you have a proxy-based corporate user behind, and many of them show up as the same IP address. Because of the cookie affinity, we'll set the cookie, and they will be directed always to the same backend server on the left-hand side. And then the other major capability is SSL offloading. So you no longer need to install SSL certificates on your 100 servers that form up the web farm. You can basically offload the SSL or terminate the SSL connection at the application gateway and then route the traffic to the backend web servers and do whatever without SSL. That appliance has entered general availability as of June or whenever it was. So you can basically provision it in a production environment and start benefiting from those capabilities. How it fits logically as a topology inside the deployment, it actually sits behind the Azure load balancer, right? So you can have traffic manager right in front exposed to your end users, traffic manager through DNS routing to either a European deployment or an Australian deployment, for example, right? And then within that deployment, you introduce the application gateway to do layer 7 load balancing or SSL offloading to your backend virtual machines that run IIS and your website, okay? So scenario, a couple of scenarios for those appliances. This is the application delivery controller, sort of what we have just discussed. So I'll skip quickly through that. The second one is firewalls, IDPs, IPS, IDSs, IPSs, and VPN appliances. The thing is that here the topology, again, is totally up to you. How many of those you bring into your virtual network, where you position them, whether you introduce a web application firewall right in front, that your internet users hit first, and then you manage the traffic from there. So this is your DMZ. Then you can have basically traffic inspection and possibly optimization between the subnets. That would be another virtual appliance in the network, so you don't need to just have one appliance. And then you can have a third appliance that manages the VPN traffic. And policies for what goes from the virtual network running in Azure back to your on-premises environment and the other way around. Or as we are going to see actually on the next slide, another one of those scenarios is for traffic optimization, right? So you can basically get something like, okay, let's go back, Barracuda Riverbed Steelhead, and provision one appliance on premises, one appliance in your Azure network. And obviously, if you have a hybrid scenario where that virtual network is connected to your on-premises environment, you want to compress the traffic in between. So you're reducing your traffic costs. You are increasing the speed of that communication, of course. And the appliance takes care of that process of compressing, decompressing, optimizing, and so on and so forth. So in terms of, this is going to be funny. Okay, so this slide here was supposed to be filled out with other names of F5s and Barracuda and Riverbed, and suddenly there is Cisco there. This is not targeted marketing in any way, I promise you. In fact, there have been others much, much earlier than Cisco onboarding that space here. Okay. So we have another 6-7 minutes, and I'll need to be very quick. So in terms of hybrid connectivities, what are your options? The first one is what we call point-to-site connectivity, where me as a developer, I can be anywhere, and I can establish a VPN, secured tunnel, IPsec over the internet into a virtual network. And many developers can do that. So you provision the corporate virtual network running in Azure, and you have your developers connecting from wherever directly to that virtual network to do dev test or whatever they do. The second one is secure site-to-site, which is basically the option of configuring, again, VPN, IPsec-based over the internet from your on-premises router over to the virtual network, right? So this is VPN-based connectivity called site-to-site in Azure. Over the internet, subject to, you know, traffic conditions on the internet, noise, and everything else. Okay, and the last option is ExpressRoute, which is the private connectivity with two variations there. One of them is MPLS, which is pure one network based. You need to enter in an arrangement with your telco provider to set that up, and then they connect you or they connect that MPLS network directly to Azure. Or the other one is what we call exchange provider option for ExpressRoute, someone like Equinix, for example, where you are responsible of how you are connected into the Equinix data center. You can have actually racks that you own there, and then they just connect through you know, dark fiber into Azure, and that's a really fast connection, of course. So that's the full range of options that you have. For the VPN routers on premises, right? So the devices that you currently have that can support that, the ecosystem is quite rich. Obviously, we have added a few more than Cisco now. We have Juniper and WatchGuard, but this slide should have been full. And yes, so those are the choices that we just discussed. So the first one on the left-hand side is the IPsec-based VPN tunnel. And then on the right-hand side is your MPLS, actually, private connectivity into the cloud. Okay. I am not going to go into the detailed differences, pros and cons. I think that you can figure that out. I just want to say that with ExpressRoute, right, everything is private. So the conversation of traffic going over the internet and unpredictable latencies and everything else is out of the picture. Okay? It's literally Azure is sitting on your network. It is still subject to slightly higher latencies, of course, because the traffic still needs to traverse the geographical length of wherever the Azure data center is hosted from your on-premises environment. But for all practical purposes, it is your own data center. And combine that with closing internet traffic off completely, you have an extended data center capacity, right? Completely secured. In fact, one of the things that we haven't discussed, and I should probably mention, is that through the routing rules in your virtual network, you can say, I don't want outgoing traffic, even if it is internet destined, I don't want it outgoing directly from my virtual network to the internet. I want the traffic to travel back to my on-premises environment. I'll do whatever I do in my on-premises environment today in terms of policies for outbound traffic, and then that Azure-born internet traffic will come to on-premises and then out to the internet. You can completely do that. It's called forced tunneling. And you can do that on a subnet basis or on a per VM basis or per virtual network basis, up to you how you want to force traffic to the on-premises environment. Okay, so those are the benefits of ExpressRoute. One interesting one is the low cost. Okay, how can ExpressRoute, which is a premium offering in terms of private connectivity, be lower cost than IPsec-based VPN over the internet? The answer is volumes. So if you are working with very, very large volumes, ExpressRoute is actually cheaper than the egress rate that you need to pay, you know, for Azure traffic leaving an Azure data center, right? And of course, if you have IPsec-based VPN tunneling, right, all the communication coming back or traffic coming back from the virtual network to your on-premises environment, it is egress traffic, right, from the Azure data center to the internet and back to you, right? For ExpressRoute, it's not how the metering works. So you don't actually pay for egress traffic. So for very large volumes of data, ExpressRoute can be cheaper than a VPN connection. A lot of people don't think about this, right? Okay, so ExpressRoute connectivity, this is basically how it works. It is highly available, so there is redundancy within the circuits that we set up. There are two peerings, actually three here, within the ExpressRoute circuit. One of them is to connect your on-premises environment to the virtual networks infrastructure in Azure. The second circuit is what we call the public circuit. The public peering. Sorry, I'm mixing terminology here. The public peering, which connects your on-premises environment and traffic to public Azure services, such as storage, SQL databases, whatever. And now we have also a peering that will go to Office 365, Skype for Business, and all these SaaS offerings that we have. So even your phone calls with Skype over Business will be subject to that private ExpressRoute traffic connectivity that you have into the Azure cloud environment. Even that is no longer unpredictable traffic going over the internet. Very, very powerful. And you can, of course, provision multiple circuits, in other words, multiple of this, right, if you are a global enterprise. So your Australian branch may be having an ExpressRoute circuit directly to Melbourne, while the Auckland and New Zealand branches have ExpressRoute connectivity to Sydney, just as an example. All right. ExpressRoute partners, I'm sure that the logos are not going to appear again. Yes, they didn't. ExpressRoute sites and partners, the map is not appearing, but what I want to mention here is that obviously we have connectivity to Sydney from New Zealand, and Melbourne is lighting up. In fact, there is already connectivity into Sydney as an edge, Melbourne as an edge location. And a new capability that we recently introduced, coexistence of an ExpressRoute connection into Azure and the Azure virtual networks you define, as well as a VPN IPsec-based connection to your on-premises environment. And what is more, if you have that setup configured, then there is automatic failover. So if the ExpressRoute circuit goes off for whatever reason, right, we are going to revert back to your VPN tunnel that you created here. And of course, there will be difference in the predictability and performance and latency and everything else, but at least you are not going to be down completely, right? So this is something to keep an eye on as well. All right, the premium add-on. The only thing that I want to mention about the premium add-on here is that this is what actually puts you on the Microsoft backbone between the data centers. And just to put that in context, I can now deploy a virtual network in North America, be connected from New Zealand with an ExpressRoute provider here in New Zealand to the Sydney data center, and then the traffic from Sydney to the virtual network that I have deployed in one of the American data centers is going through the Microsoft backbone network, okay? None of the other cloud providers do that, okay? And this is on top of the enhancements, moving from 4,000 routes to 10,000 routes, which is, again, leading in the industry. And then you can connect multiple virtual networks up to 100 to the same ExpressRoute circuit. So pretty large numbers compared to what the competition does. This is a very good comparison and how things work together in terms of hybrid connectivity. You have ExpressRoute Gateway, which is your basically ExpressRoute circuit into Azure, and the different VPN gateway offerings, basic, standard, and performance gateway. Standard being the new one. You can see the throughput limits, but more importantly, it can coexist with the ExpressRoute circuit, which does not apply to the basic VPN gateway offering. And finally, in the -2 minutes that I have, I'm not going to cover Azure Resource Manager, which is the management tier on top of all this, declarative programming of the platform. At 4:30 this afternoon, I actually have a session called deploying, managing, and something else of Azure resources through Azure Resource Manager, and that session is dedicated to ARM management in Azure. Very interesting stuff. This is what's coming to the platform. It is actually in the platform already. Come along and hear about that as well. All right. Thanks, guys. I'll be